Hi, in this screencast, we're just going to review some information that we know about energy and frequency and waves. So you've already seen images similar to this in previous screencasts. This is the electromagnetic spectrum. And here we can see that we have increasing wavelength in this direction, and that's opposite from the frequency. The frequency increases in the other direction. So we've got gamma rays, X-rays, ultraviolet light, this tiny sliver right here, which is the visible light spectrum, infrared, microwave, FM and AM radio waves, and then long radio waves. So this is all talking about radiation and particles and how they move like waves. So we're going to talk a little more about the photoelectric effect. This German physicist by the name of Max Planck proposed the relationship between a quantum of energy and the frequency of radiation. And we've seen this equation where energy equals Planck's constant times frequency. So E is the energy in joules, or a quantum of radiation. V is the frequency in seconds to the -1 power of the radiation that is emitted, and H is called Planck's constant, which is 6.626 times 10 to the -34th joule seconds. So you need to make sure you write this constant down in your notes. So if you need to, pause the video to write down that Planck's constant is 6.626 times 10 to the -34th joule seconds. Also make sure you have the equation for energy. Energy is H times V, or Planck's constant times frequency. So you'll recall a photon is a particle of electromagnetic radiation that has no mass but carries a quantum of energy, and the energy of a particular photon depends on the frequency of the radiation that it's emitting. So the energy of the photon is equal to Planck's constant times the frequency of the radiation of that particle. So let's take a look at a sample problem of this. Microwaves have a frequency of 3.8 times 10 to the 10th seconds to the -1 power. What energy is associated with this type of light? We're going to be using our equation, E equals H times V. You should recall that H is Planck's constant, and that number is 6.626 times 10 to the -34th joule seconds, so we can go right ahead and plug that number into our equation. In the word problem, it gave us the frequency, which was 3.8 times 10 to the 10th inverse seconds, so that's going to be plugged in for our variable V, which is our frequency. So now we have 6.626 times 10 to the -34th joule seconds times 3.8 times 10 to the 10th inverse seconds. When we multiply them using the scientific function on our calculator, we get an answer of 2.5 times 10 to the -23rd joules of energy. Okay, so just to review, we have two equations that we've looked at so far in this chapter. The one is the equation for energy, where energy is Planck's constant times the frequency, and the other one is where c is the speed of light equals the wavelength times the frequency. We can go further and combine these two equations by finding that frequency is the speed of light divided by wavelength. So we can extrapolate that energy is also Planck's constant times the speed of light divided by the wavelength. So make sure that you have all three of these equations in your notes. Make sure that you know what the speed of light is. Make sure that you know what Planck's constant is. If you don't have those values, go back in the screencast to find them. And make sure you have your notes complete and ask Mrs. Benke any questions that you have about any of these equations.